Physics is colliding with a hard wall. At the cosmic scale, our models break down. At the chemical scale, our engineering hits a ceiling. Both regimes are currently trapped by the geometric limits we have used to define them. For a century, we have relied on the Minkowski four-dimensional spacetime block, 3 dimensions of space, 1 of time. It maps macroscopic gravity flawlessly, but mathematically, this rigid block fails to account for quantum indeterminacy. If the future is fully predetermined in a static geometric block, the quantum probability of multiple possible futures cannot exist. It also lacks the capacity to map subjective consciousness. Biologists attempt to locate consciousness locally, looking at structural components like brain microtubules, but these physical components are mapped within that same restricted four-dimensional space. They cannot resolve the paradox of free will or the origin of subjective experience, because local mechanics are governed by the predetermined causality built into the 4D model. The four-dimensional model gives us an accurate map of biological mechanics. However, locating the mechanism of choice requires an expansion of the geometry. Down at the molecular scale, our engineering models suffer from a parallel structural deficit. We lack absolute physical control. This diagram illustrates stochastic chemistry. It relies heavily on probability. You mix molecules in a solution, apply heat or a catalyst, and wait for them to collide at the exact correct angle. It is a system defined by high entropy and high unpredictability. This reliance on statistical probability has hit a definitive performance ceiling. When you scale up complex molecular synthesis, you inevitably trigger uncontrolled side reactions. The yield drops and impurities rise as the process breaks down. We are attempting to build nanoscale technologies, using the equivalent of shaking a box of parts and waiting for them to assemble. True advanced manufacturing requires exact atomic-level spatial placement, where every bond is deliberate. Astrophysics and molecular manufacturing are stalled by the exact same problem. One is restricted by an incomplete geometry, the other is hindered by random probability. Both require a rigid expansion of spatial and temporal control. Resolving this macroscopic geometry requires examining the Lorentz transformations, the mathematical foundation of special relativity. These equations dictate how mass and energy behave as an object accelerates towards the speed of light. This chart displays the energy-velocity relationship. Notice the central vertical asymptote at c, the speed of light. If you plug a superluminal velocity, a speed greater than light, into the standard equations, the math yields imaginary numbers. Those imaginary numbers resolve into real physical values if we expand the mathematical symmetry. By upgrading spacetime from 4 dimensions to a 6-dimensional geometry, 3 spatial dimensions and 3 temporal dimensions, particles moving faster than light possess valid real energy states. In a 6-dimensional volume, our immediate present, labeled now on the chart, is the intersection mapping sensory input. Cognition extends beyond the present. Memories and abstract thoughts are mapped as geometric structures residing outside that single moment, occupying expanded off-axis dimensions. If a 4-dimensional brain produces experiences that exceed those 4 dimensions, as seen in near-death experiences where awareness continues despite 0 localized brain activity, it suggests an interface with a wider volume. The 6-dimensional model treats these events as empirical data points, where consciousness navigates the expanded temporal topology once the 3D biological anchor is suppressed. By treating time as a 3-dimensional geometric volume, subjective experience becomes a mathematically mappable coordinate system. That same demand for rigid spatial control is solving the microscale bottleneck. To assemble complex molecules, we must impose macro-level physical constraints onto individual atoms. This graphic outlines the solution. We abandon probabilistic fluid mixing and shift entirely to positional chemistry. We replace random collisions with deterministic sub-nanometer mechanics. DNA origami functions as a programmable physical scaffolding, a mechanical jig designed to hold matter in exact orientations. This illustration diagrams a DNA microfactory. Notice the structural DNA arms acting as mechanical actuators, physically gripping the carbon nanotube. We achieve a positional accuracy of 0.1 nanometers, applying exact actuator force. We define the reaction path directly, removing temperature-driven collisions. We are engineering absolute spatial control over individual molecules. The era of chemical probability has been replaced by mechanical certainty. Executing these advanced spatial and theoretical models in real time requires an entirely new computational architecture. A single technology is insufficient. This charts the hybrid workflow. At the simulation layer, quantum processors calculate transient binding states. This data flows into the orchestration layer, where AI refines it into predictive models. Finally, at the interface layer, DNA nanotechnology translates these digital models into physical reality with atomic precision. This schematic illustrates the convergence advantage. By stacking quantum processors for natural complexity, AI for data orchestration, and nanotech as the physical interface, the results are multiplicative, scaling exponentially past the limits of isolated systems. This tripartite architecture functions as a read and write operating system for physical reality. It maps quantum transient states and assembles the exact macroscopic structures. The velocity of this convergence stack exceeds the capacity of traditional commercial and regulatory structures. Legal frameworks cannot keep pace with the physics. This graphic maps the disparity. Standard patents operate on an 18-month cycle, but AI and quantum algorithms evolve in weeks, making patents obsolete before granting. Therefore, firms are abandoning patents. Core value, like AI training data, is now encapsulated and guarded strictly as trade secrets. To defend this territory, researchers aggressively publish their physical frameworks into the open source. This generates a wall of prior art, effectively blocking any competitor from patenting the structural math. True frontier technology cannot be protected by static legal definitions. The sheer, unreplicable velocity of the hybrid physics architecture acts as its primary defensive moat.